Hello class, and today I'm going to be talking about 1.3 fractions. Um, so this is the next section that we're going to try to cover in our book. And let me know if this is a little bit too much by the end of it, because looking at my notes, this is a lot of definitions I'm going to throw at you. So I hope it's not too overwhelming. But in objective 1, we want to write fractions in simplest form. So any fraction, right? So let's just write 2 over 9 is made up of one number on top of the dividing line called the numerator, one number on the bottom called the denominator. I hope I'm spelling that right. Denominator. Yeah. So the numerator and the denominator, this is going to be a part of every single fraction. So how do we write a fraction in simplest form? Well, it has to do with writing the denominator so that you cannot divide it, or you cannot divide either the denominator or the numerator by any of its shared factors. Basically, it won't have a share factor. So what is a factor? So a factor, let's go over that. So let's say we have a number 15. Its factors are 1, 3, 5, and 15. So why are these called factors? Well, we can multiply 3 and 5 and get 15. We can likewise multiply 1 and 15 and get 15. So these numbers are called factors because we can divide 15 by them and get another number. So when a numerator and a denominator do not have a shared factor, we can't cross out or we can't eliminate any part of the number. Let me give you something that we can cross out, so maybe it makes it a little clearer. So if we have a fraction 4/6, we can write this in its factored form, each number in its factored form. So we have 2 times 2, which are the factors of 4 other than 1 and 4, and we have 2 times 3, which are the factors of 6 other than 6 and 1. And we can see here that there's a shared 2 right here. There's a 2 on the top and a 2 on the bottom. So that means that we can actually cancel out these 2's, because when we divide 2 by 2, we just get 1, right? So we can cancel out these 2's, and what we're left with after we do that cancellation is 2/3. So right here, this is 4/6 in simplest form. Now, what you might say is, well, what if there are a lot of factors? So what do I do with a number with a lot of factors? How do I know which factors to simplify them into? Well, this is where something called prime numbers comes in to help. Prime numbers. So prime numbers are numbers that can only be divided by 1 and itself. So numbers with only 1 and itself as factors. So prime numbers are numbers with only 1 and itself as factors. So that means if we have a fraction with prime numbers, so we just have some p and some p, so p1 and p2, and they're both primes, well then we know this factor, or this fraction, is in simplest form because they don't have any shared factors. Excuse me. They don't have any shared factors. So it has to be in simplest form. So whenever you take a number like 12, you want to break it down into its prime numbered factors. So we can break this down into factors of 4 times 3, but 4 isn't a prime number, right? Because 4 has a factor of 2. So we'll want to break this down into 2 times 2 times 3. So then, if 12 is ever in a fraction with something like 14, whose prime factors are 2 and 7, well, we know that we can cancel out a 2 here because they share 2 as a factor. But we can't cancel out anything else because 2, 3, they're both primes, and 7, that's a prime. So they don't share any factors together, 2, 3, and 7. So therefore, that fraction must be in simplest form. And in fact, something like 6th sevenths or 7th sixths is a fraction in simplest form. So let's talk about composite numbers. Well, actually, yeah, let's talk about composite numbers, then the fundamental principle of fraction, and then we'll talk about multiplication and division. Okay, composite numbers. These are simply put not primes. So these are numbers like 12, 14, 6, 4, all those numbers that we were putting into primes on that last slide, those are called composite numbers. And those are what we're going to break down into primes in order to simplify our fractions. Now, in your book, they go over what's called the fundamental principle of fractions. Fundamental principle of fractions. So what is this? So I actually kind of already explained this, or at least used it in one of my examples. The fundamental principle of fractions simply says that if you have A times C over B times C, well then this fraction equals A over B. Why? Because C over C equals 1. Again, you can think of a fraction as saying, this is, let me get a different color. This is how many pieces we have, and this is how many pieces were made. So you have C pieces of the C pieces that were made. Well, then you have the whole thing, which is 1, right? So the fundamental principle of fractions is what we use once we break everything down into primes. So once we have everything down in the primes, we cancel out those primes that show up on both the top and bottom because they make a whole. Okay, so now we're going to use this to multiply and divide fractions. Okay, so here I have a simple multiplication. A over B times C over D. I want you to pause the video real quick and just try to take a guess of what this answer is going to look like. Go ahead and pause it. Okay, so the answer is that we're going to have A times C over B times D. This is how we multiply fractions. All we do is multiply the top and put it as the top, and multiply the bottom and put it as the bottom. So we can do a quick, real simple example by looking at something like 1/3 times 2/5. So this is going to equal 1 times 2 over 3 times 5. This is equal to 2 over 15. So 1/3 times 2/5 equals 2/15. Now let's talk about division. Here we have the same fractions, except we're going to be dividing. So when you divide by fractions, you do something a little bit different. And it might look a little complicated at first, but I promise you it's not as hard as it looks. So when you divide fractions, you actually multiply by what's called the reciprocal. Again, I'm hoping I spelled this right. Reciprocal. So what is the reciprocal? So the reciprocal of A over B is equal, let me do like one of these. The reciprocal of A over B is B over A. This is because we define the reciprocal of a number as the number that when you multiply it by its original number, you get 1. That might have sounded confusing, but all it means is that, so if you take A, and what I might write is A to the minus 1 to denote A is a reciprocal, then you get 1. So this is just a definition. We just want to define something as whatever, we just want to define something as the number that when you multiply it by another number, you get 1. So that's all we wanted to do. It's just kind of math wanting to give a name to something. So you can see that when fractions come into play, the reciprocal of any fraction is just going to be the numbers reversed. Because when you have A over B times B over A, right, you get A times B over B times A, and you can just cross everything out. Sorry. And you get 1. So when you divide by the reciprocal of the second fraction. So that's why I wrote this as this. So whenever you think A over B divided by C over D, you replace that divide by multiply by the reciprocal. So A over B multiplied by the reciprocal of C over D. So you get A over B times D over C, which is equal to AD over BC. Again, we can try an example. Let's do the same one that we did last time. So what it was 1/3 divided by 2/5. So this is going to equal 1/3 times 5 over 2. Sorry, I'm running out of room. And this is equal to 5 over 6. And that is how we divide fractions. So I'm sorry this video was a little bit long, guys. I warned that it was going to be a little bit of material, but I hope you guys enjoyed it. I hope you guys understood it. If you have any questions, feel free to email me or just ask them in the comments down below. Okay, y'all have a good one, and I'll see you next time.